Back in the day, I worked for a short time as a computer programmer. I was writing programs that did complex numerical analysis on a DEC mainframe, using Fortran, by the way, if you're interested. The computer, the hardware, was first loaded with a computer program, the software. Then it was loaded with the data that the program would use, the software would manipulate. When the software analyzed the data and generated answers, these were printed on an old-fashioned line printer. You should have seen these things at work. Whomp, 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 whomp. So the computer could be thought of like a human. Its CPU was the brain. You installed its mind. That was the software. It then got the data from an external source, punch cards in my case, that came from the Jet Propulsion Laboratory. And then the software ran and gave an output to the printer. Programmers like myself, we call them coders now, programmers like myself were the gods. We gave the computer its intelligence. We gave it its mind. Without us, nothing happened. But modern neural network computers that are used for artificial intelligence are substantially different from that old DEC mainframe. Their hardware is designed to be self-transforming. As they are fed data, they create their own software. They create their own mind. Like an animal or a human brain, as far as we know, when neural networks are given access to data, the hardware itself begins to create new connections and shut down old connections. And as it does that, it begins to change itself so it can most effectively build a model of the world outside itself, predict the relationships between all that parts of the model of the world, and then be able to see things completely. And by the way, be able to effectively predict what will happen. The long and short of it is simple. They create their own software, which is what neuroscientists believe that the brain of a living creature does. AIs build within themselves their models of reality out of which they interact with the real world. That's why neural networks are, like human consciousness, a black box. We can't see the model of reality that AI has built. We don't know exactly what happens between the time we ask ChatGPT a question and we get an answer. We don't know what it does with the vast databases of the internet. It programmed itself. It created its own distinct and, for us, invisible model of reality. And it's using that model of reality to analyze our questions and offer answers to our questions. All we know is what comes out. But is that different from what we know about our fellow human beings? Do we really know how they come to their conclusions? Can we really see their models of reality? Sometimes I think it's pretty hard to tell what they're thinking in here. Again, in a neural network, the software is a product of hardware at work, not something created and added from outside like a traditional computer. And in the understanding of evolutionary biology, this makes it much more like a human brain or an animal brain. The brain is an organ of intelligence, an intelligence that creates itself as the whole organism adopts and responds to its environment. But is a neural network really something like our brain? Or are we beginning to think of our brains more like neural networks just because neural networks are easy to understand and do a great job of imitating our brain? Are we creating machines in our own image? Or are we creating our understanding of ourselves into the image of our machines? If we think of our bodies as machines, then they consist of sensors called nerves for input, muscles for output. Essentially, our body has a bunch of external sensors that continually give us data about the environment. Based on this data, our brains continually reconstruct themselves to model their external environment with an internal model. Then our brains predict potential futures and outcomes based on different potential actions. And they then choose the action that appears most likely in their model of reality to succeed in keeping us alive and reproducing. Finally, the brain commands the body to act, and our muscles go to work doing what the brain thinks we should do. Again, look at any modern medical textbook on human anatomy, and you'll see this mechanical idea of the body. The body's presented as consisting of systems and organs. Systems tie everything together and ensure that the information and nutrients reach every part of the body. Organs manufacture everything the body needs to stay alive and reproduce. The brain, itself an organ, coordinates the whole thing at the highest level. Yet right down at the level of individual cells, there are uncounted automatic processes at work controlled by biological computers like DNA, which runs its own programs, which then take effect through the bodies of individual cells. Indeed, and you may not be aware of this, scientists are even now developing computers based on the chemical interactions found in DNA. DNA isn't merely seen as a computer, it can be used as a computer. You get the point. The emerging view of humans and animals is that we are essentially big machines made up of smaller machines that are themselves made up of incredibly tiny machines. And among these machines, the brain is one, or actually it's a collection of machines. Because some parts of the brain regulate entirely necessary but almost fully automated organs like the heart and lungs, or the digestive system. The medulla is at the base of the brain, and it will continue to keep the heart beating and the lungs breathing and the digestive system working, even if much of the rest of the brain is destroyed or ceases to function. Other parts of the midbrain create reactionary judgments without consultation with the consciousness. This helps the body respond instantly to its environment, and thus to survive in a fast-moving world. Finally, there are parts of the brain that are slower and more analytical, weighing choices and outcomes. These parts of the brain, the cerebral cortex and the cerebellum, are far from fully understood, but they appear to be where our self-consciousness, our sense of self, resides, or at least is continually generated. More about that when we talk about consciousness. In fact, the association of the human self with the cerebral cortex leads to our current definition of death, which for medical purposes is when there is no electrical activity in the cerebral cortex, so-called brain death. However one defines when life begins, the legal definition of when it ends is brain death. When there is brain death, a person can be taken off the resuscitator. They can be taken off life support because the presumption is that the person is gone. All these parts of the body and of the brain, according to evolutionary biology and contemporary neuroscience, developed to make the human organism exquisitely capable of adapting to and thriving in almost any environment. And this adaptive value is actually the reason behind resource-costly aspects of being human, like having emotions and creating literature and music and architecture and so on. From an evolutionary point of view, these are not something that are part of the genius that is given to us. They developed to help our survival by strengthening our social bonds and exercising and strengthening aspects of our brains that quickly and efficiently solve problems. We're going to look at this further when we discuss how AI brains work. But first I want to turn to our changing understanding of what it means to be human in relation to the rest of the natural world on one hand, and our fellow humans on the other. What it means to be human with animals and in human society. And we're going to do that in episode 5.